Now its mean speed and the magnitude of mean velocity r. That means we want to find the mean speed, that means average speed, to find average speed and average velocity, to find mean average speed and average velocity. Okay, now the point is ours half circle. Now see here, a particle travels half circle. Okay, let O is the origin or the center of that circle. Okay, and the particle starts from A and end to the point B. Okay, and the radius of that circle is R. Okay, now to find the average speed. Okay, so average speed means the total distance traveled by particle. Okay, now see here, the total distance traveled by particle is total distance traveled by particle is half of the circumference. Okay, that means half into circumference of circle is 2 pi r. That means pi r is the distance traveled by a particle. Okay, now we find the average speed. Average speed is equal to total distance upon total time. Okay, so total distance is given pi r. Okay, divided by time period. Time period is given t0. That means the average speed is pi r upon t0. Okay, now to find the average velocity. Okay, velocity formula for velocity is displacement upon time. The particle it starts from point A and end to the point B. Okay, that means the shortest distance between A and B is known as displacement. So the shortest distance is this. That means the diameter of circle. So the total displacement is equal to diameter, that means 2r. So the average velocity is equal to displacement upon time. Okay, so displacement is 2r and time is t0. Okay, so the average magnitude of speed is average speed is pi r upon t0 and the magnitude of velocity is 2r upon t0. Okay, understood? Okay, now see next numerical. A particle moves 3 meter north. A particle moves 3 meter north, then 4 meter east and 12 meter vertically upward. Okay, then find its displacement. Okay, first of all we will draw a diagram. Okay, a particle moves 3 meter north. Suppose this is the point A, which is the initial point. So from this particle moves 3 meter north. Okay, 3 meter north. Then 4 meter east. Then the particle moves 4 meter east. Okay, and 12 meter vertically upward. That means that particle moves 12 meter vertically upward. Suppose north example, this we want to say that x. So 12 meter upward. Now to find the displacement. Okay. Now see here, point A is the initial point. A is initial point and x is the final point. Okay. So now to find the displacement. Okay. So now see here, first we will calculate this AE. Okay. So here is the right angle triangle. So by using Pythagoras, okay, now see here, by using Pythagoras, in triangle A and E, okay, in triangle A and E, so we get AE square is equal to AN square plus NE square. So by substituting the values, we get, that is 3 square plus 4 square. Okay, for look at equation number 1. That is, the value of this is 3 square plus 4 square. Okay. Now remove this side. So this is then again perpendicular. That means this is the point x. So this is the 12 meter, and this side we get 3 square plus 4 square. So this point is A. Here point is E. Now to find this, okay, so we get displacement. So again we apply Pythagoras theorem. Okay, so we get ax square is equal to sin 1 square plus sin 2 square. Okay. Sorry. Okay. So sin 1 square plus sin 2 square, which is equal to this square. So we get 3 square plus 4 square, because sin 1 square root get neglected, so 12 square. Okay, so now we get 3 square 9 plus 60 plus 144, so which is equal to 169. So taking square root on both sides, so x is equal to square root of 169, that is 13 meter. Okay, just we use only Pythagoras and solve. Now see next numerical, a particle moving in a straight line from A to B. So we can draw a diagram. A particle moves from point A to point B. Okay. For the first half of time with uniform velocity v. That means for first half time period. Okay. For first half time period, the uniform velocity v1, and for next half time with uniform velocity v2, and for next half time period with uniform velocity v2. Okay. Then the average velocity of particle. Then the average velocity of particle. Okay. So we know that the formula for average velocity. Average velocity is equal to displacement upon time. Okay. So time is given, the average speed also given. So we want to find first displacement. d1, and for the next half, that is d2. So we will find the distance. So distance d1 is equal to velocity into time. For first half, velocity is v1 into time period is half, so t by 2. Okay, so this is coming as equation number 1. Similarly for second, v2 into t by 2, calling as equation number 2. Okay, now we are substituting these values in formula. Average velocity is equal to total displacement, that means v1 into t by 2 plus v2 into t by 2 divided by total time is t. Okay, we can take t common, so t into v1 divided by 2 plus v2 divided by 2 divided by t. So t get cancelled, so which is equal to v1 plus v2 divided by 2. v1 plus v2 divided by 2. This is the velocity of a given particle. Okay, now next numerical. A car moves from A to B with uniform speed v1 and returns to point A with uniform speed v2. The average speed for this round trip is. Okay, so first we draw a diagram. That car is moving from A to B. Car is moving from A to B. Okay, so the total distance is d. Okay, total distance is d. Now see here, a car is moving from A to B with uniform speed v1. That means car is moving from A to B with speed v1. Okay, and it returns to A. That means it again travels from B to A with uniform speed v2. With uniform speed v2, then find the average speed for this trip. Distance is given, speed also given. Okay, uniform speeds are given, but time is not given. Okay, so for path A to B, for path A to B, time t1 is equal to, formula for speed is displacement upon formula for speed is distance upon time. Okay, so time is equal to distance upon speed, so we get d upon v1. Okay, similarly for path B to A, that means that car is returns to A, so the time period t2 is equal to d upon v2. Okay, now to find the average speed. So the average speed is equal to total distance upon total time. Okay, now see here, total distance is, the car is moving from A to B, that means it covers a distance d, and again it returns from B to A, so it also covers a distance d. So the total distance is d plus d divided by time, total time d upon v1 plus d upon v2. Okay, so we get 2d upon cross multiplication d into v2 plus v1 plus v2 upon v1 v2, dt get cancelled, so we get 2 into v1 v2 upon v1 plus v2. This is the average speed. This is the average speed of that car. Okay. Okay. Now next numerical. A particle moves from A to B for the first half distance with a uniform speed v1. For first half distance, uniform speed is v1, and for next half distance with uniform speed v2, the average speed of the particle is. Okay. Now see, a particle moves from A to B, moves from A to B. Okay. For first half distance, that means divide the uniform speed is v1. Okay. And for next half distance, the uniform speed is v2. Okay. So to find the average speed of that particle is. Okay. Now distance also given, speed also, uniform speed also given. Okay. So for the average speed we require time period. So first half, that is for first half time period t1 is equal to. Okay. So we know that the formula for speed, that means speed is equal to distance upon time. Okay. Therefore time is equal to distance upon speed. Okay. So we get time period t1 is equal to distance is d by 2 upon speed v1. So similarly t2 is equal to d by 2 upon v2. Okay. So now we find the average speed. So average speed is equal to total distance upon total time. Okay. So now see here, total distance is d by 2 plus d by 2, that means d upon total time, d by 2 upon v1 plus d by 2 upon v2. So we get d upon d by 2 v1 plus d upon 2 v2. So base get same. So we get 2, or we take d common. So d into 1 upon 2 v1 plus 1 upon 2 v2. dd get cancelled. So we get cross multiplication. So 1 upon 2 v2 plus 2 v1 upon 2 v1 into 2 v2. Okay. So this is going to upside. So we get 4 v1 v2 upon 2 v1 plus 2 v2. So 2 get common. So we get 2 and 2 to the 4. So 2 v1 v2 upon v1 plus v2. Okay. This is the average speed of that particle moves from A to B. Okay. Understood? Okay. Now next numerical. If a car covers 2/5 of the total distance with speed v1 and 3/5 distance A to B. Okay, this car covers 2 feet distance. Okay, so this car covers 2 feet distance with speed v1 and 3 feet distance with speed v2. Okay, now to find the average speed. Okay, so first of all we find the time. So t1 is equal to distance upon speed. Okay, so similarly t2 is equal to distance upon speed. Okay, now according to the formula of average speed is equal to total distance upon total time. Okay, so we get total distance is d upon total time, 2 feet of d upon v1 plus 3 feet of d into divided by v. Okay, now see here d get common, so d upon d into 2 by 5 v1 plus 3 by 5 v2. Okay, dt get cancelled, so we get 1 upon this get cross multiply, so 2 5s are 10 v2 plus 50 v1 divided by 25 v1 v2. Okay, so we take this is upward side, so we get 25 v1 v2 divided by 10 v2 plus 50 v1. So we can take 5 common, so we get 25 v1 v2 divided by 5 into 2 v2 plus 3 v1. So 5 5s are 25, so this is equal to 5 v1 v2 divided by 2 v2 plus 3 v1. Okay, 5 v1 v2 upon 2 v2 in plus 3 v1. This is the average speed of that car. Now see next numerical. A car travels half distance. A car travels half distance with constant velocity of 40 meter per second, and the remaining half with a constant velocity 60 meter per second. Okay, now the average velocity of that car is. Okay, now see here, suppose a car is moving from A to B. Okay, it covers half distance, that means d by 2. Okay, with velocity 40 meter per second, and the remaining half distance d by 2 it covers with velocity 60 meter per second. Okay, then find the average velocity of that car. Okay, so first of all we will find the time period. t1 is equal to distance upon time, so which is equal to d by 80. Okay, so similarly for second half, that is d by 2 upon 60, so which is equal to d upon 120. Okay, now the formula for average velocity is equal to displacement upon time. So displacement is d upon time, total time. That means d upon 80 plus d upon 120. Okay. Now see here, d upon, take it common. So 1 upon 80 plus 1 upon 120, dd get cancelled. So we get 1 upon 120 plus 80 divided by 120 into 80. So this will be to upward side. So we get 120 into 80 divided by 200. So we get 12 96. So 9600 divided by 200. 0 get cancelled. Okay, 0. So 96 divided by 2, which is equal to 48 meter per second. Okay, understood this? So according to the formula of average speed, okay, so we calculated the average velocity. According to the formula of average velocity, we calculated the average velocity of that car. So the average velocity of that car is 48 meter per second. Now see, one car moving on a straight road, it covers 1/3 of distance with 20 km per hour and the rest with 60 km per hour. The average speed is, okay, suppose that car is moving in a straight line, so A to B, okay, so that car covers 1/3 of distance, okay, 1/3 of distance in with speed 20 km per hour. Okay, and remaining, that means 2/3 distance is covered with 60 km per hour. Okay, so now to find the average speed, so time given is equal to distance upon speed, so it is equal to d upon 60. Okay, and for next, that is 2/3 distance is covered with 60, that means 2d upon 180, which is equal to d upon 90. Okay, so the average speed is equal to total distance upon total time. Okay, so we get total distance is d upon time, d upon 60 plus d upon 90. So we get d upon d into 1 upon 60 plus 1 upon 90. So dd get cancelled. Now see here, 1 upon kilometer per hour. Okay.